Alright, so we're looking at the answers for the revision worksheet. So this would be question 1, 2, and 4. So if you look at the first question, we are looking at hydrogen chloride. Now, the IDE suggests to you that it is a compound. And a compound is made up of 2 or more elements. So the first element you can find in the periodic table is hydrogen, and the next element would be chlorine, and we know that from the naming that you are changing the last few letters into a IDE. So in order to find the particle diagram, we are actually looking at 2 different circles. So it will look something like this. One circle for hydrogen and a different circle for chlorine. So all we need to do is to find which one looks like this. And you realize that C looks exactly like what we have drawn. So the answer will be C. Now oxygen can be found in a periodic table, so it is an element. But remember, oxygen exists as diatomic molecules, so it should be 2 similar circles together for oxygen. So if you look at the particle diagram, it is A that looks like what we have drawn, so the answer here is A. Now for carbon tetrachloride, again the ID suggests to us that it is a compound. But the tetra means that there are 4 chlorines in this case connected to 1 carbon. So it should look something like this. 1 with 4. Or it can be a big circle in the middle with 4 tiny ones. Okay, as long as you have 4 of the same size, it doesn't matter whether it's bigger or smaller. So the one that looks like this will be I. So the answer is I. Now for the next one, we are looking at a mixture. It means we are looking at things that are not chemically combined. And we realize that water has the characteristic Mickey Mouse shape, that is a compound. And hydrogen chloride is what we have drawn earlier, which is this one. Okay, so we are looking for a mixture of Mickey Mouse and a hydrogen chloride molecule. So the one that looks most like this would be F in this case. The Mickey Mouse here and the hydrogen chloride there. Okay, so the answer here is F. Now similarly, for the mixture of nitrogen and sulfur dioxide, nitrogen exists as diatomic molecule, and sulfur dioxide looks quite like water because there's 1 sulfur and 2 oxygens. So again, we are looking at this, the diatomic molecule, and a Mickey Mouse shape because there's 1 sulfur and 2 oxygens. So which one looks like it? It will be H. For the next one, we're looking at 2 elements. So there are many answers for this. One of the answers would be B. Now if you realize, B contains this, which is 1 element, and this is another element as well. Okay, another answer would be this, where same size circles are 1 element, and the remaining is another element. G is 1 as well, where this is 1 element, and this is another element. So there are 3 possible answers for this. Okay, B, E, or G. For the mixture of 2 compounds and 1 element, so the answer is J. that this is one compound, for example, hydrogen chloride. This is another compound, for example, sulfur dioxide, and this is the element. Okay, last but not least, 2 elements and 1 compound. We're looking at D. So this is one element, and this is another element, and the Mickey Mouse shape is a compound. So for question 2, we're looking at chemical formula and whether or not it's an element or compound. So compound is very easy to identify as long as it has 2 different chemical symbols. Now we can find the chemical symbol from the periodic table. So PCl5 is a compound. But if you look at oxygen itself, then oxygen is an element because it doesn't contain more than one kind of element that's found in the periodic table. Similarly, for this, it contains 2 chemical symbols found in the periodic table, chlorine and fluorine, so it is a compound. But remember, when you write the Cl for chlorine, do write the cursive L. So these are the answers for whether or not they are elements or compounds. So we'll go on to the naming. So this contains 1 phosphorus. So remember, you just copy from the periodic table. This is phosphorus. And the next one is it contains 5 chlorine. So it's actually a penta. And it's actually pentachlorine. But remember, we changed the last few letters to IDE. So it's phosphorus pentachloride. So sulfur, there's only 1 sulfur because there's no di or tri in front of it, so it's S. And the dioxide indicates there are 2 of the oxides, and oxide means that it's oxygen, so it's SO2, and remember it is a subscript 2. Similarly, you should be familiar with carbon tetrachloride. Okay, remember we should have a curly L for this, CCl4. This is 1 silicon and 2 oxygen. So again, it's very similar to this, 2 oxygen. So instead of sulfur dioxide, it is silicon dioxide. Now this is an element, oxygen gas, but you must remember that oxygen exists as a diatomic molecule. So when you refer to oxygen gas, the one you breathe, it is O2 and not O. For helium gas, it exists as an atom, individual atom, so it's just He, and remember it is a small letter E as per the periodic table. Now for this one, it's slightly more complicated. Here we have nitrogen there, and we also have oxygen. Now there are 2 nitrogens here, so it's actually dinitrogen, and there are 4 oxygens, so it will be tetraoxygen. And remember, we changed the last few letters to IDE, but when there are 2 vowels here, we actually take out the A, so it's dinitrogen tetroxide. Now this is very similar to if we have 5 oxygens, so example, pentaoxide. Okay, we do not use this. Okay, we actually say that it is pentoxide. Okay, without the A. So for this, okay, there's 1 chlorine and 1 fluorine, so it's chlorine and fluorine. And we change the last few letters to IDE. And remember, we should add the mono in front of the second element. We don't need to add it in front of the first element, but we must add it for the second element. And the last one would be carbon tetrahydride. Comes from the word hydrogen. Okay, and we change the last few letters to IDE. Now this is also methane, the gas found in your fart. Now for the last question, question 4, we are looking at preparing cold isotonic drink. Now, does anybody know what an isotonic drink is? You should see it at the drink store. Examples of this are like 100 plus or H2O, not water, but actually H2O like the one found in your drink stores. They are called isotonic drinks because they actually replenish the minerals in your body. So iso actually stands for same. It's the same concentration of minerals as in your body. So we are looking at preparing this drink in the shortest amount of time. But if you look at the question, the final product must be a cold isotonic drink. Now, I don't think you would like to drink hot 100 plus or hot H2O, right? So we are going to prepare a cold isotonic drink. So the three factors that affect how fast something dissolves is number 1, temperature. And number 2, as you're very familiar, as we did the challenge in the lab of dissolving the sugar cube, would be the rate of stirring. Now remember, we also needed to crush the sugar cube, so the surface area of the solute matters as well. The smaller the surface area, the faster the rate of dissolving. So in this case, when we are dissolving this isotonic tablet, which is like a sugar cube, we should first grind it in powder form, and of course we need to mix it. And then we stir it, and hopefully you stir really fast, and we add the ice to the water. Now, we do not add the ice to the water first in this case because this will decrease the temperature. Then it will slow down the rate of dissolving. So we add the ice last. It's the same thing when you have bought a 100 plus from the NTUC, for example, you add ice cubes last, or when you're preparing Milo, you dissolve it in hot water and then you add ice cubes later. So the answer in this case would be D.